even though they're a molecular compound when we put them into water. So it's like, say you had hydrogen sulfate and you dissolve that in water. Now you have hydrosulfuric acid. Okay? See that? Yeah. So these acids actually have ions in the solutions, and that's why we say acids ionize, because since they don't start as ionic compounds, but they make ions. It was super trippy, right? Yeah, it's not normal. Okay? They turn litmus paper red, as we've seen before. And when we write out your dissociation, or well, these are actually called ionization equations. When it's an acid, yeah.
Can I go to the washroom?
Yeah. When it's acid, we call it an ionization formula, not a dissociation formula, because it ionizes. So, for example, if we have H2SO4, our hydrosulfuric or sulfuric acid, it will dissolve in the water and ionize. So I put a 2 in front of the H plus because I have 2 hydrogens in front of the sulfate, and I say it's aqueous because since it's acid, it will be aqueous. And then I have my SO4 2 minus aqueous. So, okay, so ionization, so this is the definition, is the process by which a neutral atom or molecule is converted to an ion. Now, Arrhenius, so that's spelled Arrhenius, he proposed that acids ionize by interacting with water solvents. The idea is that the H plus causes the litmus paper to turn color. But in actuality, okay, what ends up happening, and we do this more in Chem 30, you actually don't need to know this right now, but this H plus ion, it actually joins with a water molecule and makes something called hydronium, which is H3O plus. Okay? So this is called a hydronium ion. This is what makes acidic properties. Yeah. So you don't need to know that till Chem 30, but yeah. All right. So now, so what I want you to do to develop as a skill is to be able to look at a compound and predict how it's going to dissolve in water, or if it's not going to dissolve in water. So you're going to need your solubility charts for this. So the first thing you need to think of to yourself when you're trying to determine how these will look is, number 1, is it molecular or is it ionic, right? Because that solubility chart can only be used for what? Ionic, okay? So if it is ionic, you go to the chart and you can use that. If it is molecular, what are our rules that we can use? If it's nonpolar, will it dissolve? So think about something that's nonpolar, like oil. Does it dissolve in water? No. Okay, so nonpolar things don't dissolve. Polar things will dissolve slightly, or be soluble slightly. And then polar molecules with hydrogen bonding will dissolve a lot. Okay, so you're going to have to use your bonding unit a little bit and think about polarity, okay, when you're doing this. for example, potassium chloride. So write out the formula for potassium chloride. That's the first thing you do. Is potassium chloride ionic or molecular? It is ionic. It's made from ions. So we have our KCl. Okay. We can assume it starts with solid, and this is a dissociation or ionization equation. So our arrow represents like when we put it into water. So now look at your solubility chart. If you took KCl and tried to dissolve it in water, would it dissolve? Yes, most definitely. So it is aqueous now. So you just write your potassium ion and your chlorine ion. And show, because we're showing that it's dissociating. Okay, so this is an ionic compound that is dissociating. Okay, next one. Carbon dioxide. Ionic or molecular? Molecular. Okay, so write it out and know that it's molecular. Now, let's think about it. Is carbon dioxide polar or non-polar? So some of these you should just kind of get used to knowing what they look like. So remember our carbon dioxide had a shape like this, a double bonded to the O's. So what is this type of shape? It's just one line, so this is linear. And I know it's linear because like there's no bonding electrons up here pushing things away. So it's linear, so is it polar or non-polar? It is non-polar, so it won't dissolve. So we just say CO2 gas, okay? So it's not going to be dissolved into the solution. Okay, try writing out the rest of the compounds. Okay, so our solid hydrogen nitrate. So when you see this, you should kind of think acid, right? It's not, we don't call it an acid at this stage because it's a solid, but say we dissolve it in water now, so that's definitely an acid. So we show our hydrogen ion and our nitrate ion, and it's because this acid. What verb do I use for acids when they're put into water? Ionize or dissociate. They ionize, okay? Acids, because think about it. So let's let's write this down. Ionize, okay? Because think about, like, acids didn't start as ions, they started molecular. So if they become ions, it's like they ionized, right? It's like, okay, let's say, okay, Rachel, you don't like basketball, do you? No, okay. So let's say we converted Rachel, and now she only became a basketball player. We would say she's basketballized. Okay? We converted her, and so it's like she wasn't originally a basketball player, and then we made her a basketball player, so it's like she changed, so we basketballized her.
So is it because like you break them up into their causing them?
Yeah, because this compound is actually molecular. So when we put it into water and it behaves like ions, it wasn't ion before and now it is, so we say it's ionized. Yeah. But when when ionic compounds go in water, they dissociate. So next, aluminum sulfate. Find it on your solubility chart. Will it be slightly soluble, or will it be soluble and dissolve? Yes? No? Soluble? Okay, great. So we have then our aluminum ions and our sulfate ions, but you need to balance the ions. So on the left side I have 2 aluminum, so I need to put a 2 in front of my aluminum ion. And in front of my sulfate ion, what should my coefficient be, Evan? 3, yeah. Because that 3 in this compound applies to the whole thing. Yeah, everything in the bracket. So then, since this was an ionic compound, what verb do I use to say as it went into the water? Dissociate, yeah. Okay. Next one, sodium phosphate decahydrate. Try and write that one out. Find it in your periodic table. Make this compound. Remember that decahydrate means like dot 10 H2O?
I just have a question.
Hi, yeah.
About number 3, because you said it's ionic, but then it ionizes?
No, number 3 is a molecular compound. It's like it's an acid, but we can't call it an acid when it's in its solid form. So it's solid hydrogen nitrate. It's a very awkward thing because it's in its actuality, it's molecular compound, the way it sticks together, but we kind of name it ionic.
Yeah, because it's ionic solubility.
Yes.
So,
Because it's because it's an acid that it's so polar that it behaves like an ionic compound. So originally it's like an extremely polar molecular compound that it behaves ionic. Kind of remember on our scale of forces that there was a gray area between ionic and those other molecular forces. So this is molecular, but it behaves ionically. Its bonds behave ionically. It's ironic.
okay.
No, it's ionic. All right. Okay. So does this dissolve sodium phosphate? And you don't need to worry about the decahydrate. Just think sodium phosphate. Find the sodium phosphate on your solubility chart. Yes? No? Slightly. So sodium phosphate. Sodium. Remember group 1 ions. Sodium is a group 1 ions. So when you see it here, it's in this category. Very soluble, right? Yeah. So it does dissolve into its ions. But we need to write in, the coefficients. You don't need to worry about the H2O because it's dissolved in water. So it's just more water with the water. So it's like saying, oh yeah, there's 2 extra water amongst the 100 million. You know, it's like whatever. Just doesn't matter. Okay, ready? Gasoline. So I'll give you the formula for gasoline. So is C8H18 liquid at room temperature, right? Gasoline, what do we think about it? Does gasoline dissolve very well in? No. And if we wrote out the chemical compound, so we have 1, 2, 3, 4, 5, 6, 7, 8. And then there's hydrogens on each carbon available, okay? This is a very non-polar molecule. Remember I said like with these hydrocarbons, you just say that it's like they're all non-polar. If I had an O at the end here, then it would be polar. But because it's just all C's and H's, it's non-polar. So that's why it won't dissolve in water. And you just know that by experience too, right? So it's just gasoline liquid. It'll just stay as liquid, gasoline, and water. Yeah. Okay, barium sulfate. What do you do with the dead chemist? Right? Funny. So our barium sulfate solid, in our solubility chart, oh, you guys don't have sulfate, do you? In your solubility chart. Do you have, oh, yeah, you do, yeah. So it's only slightly soluble, so it stays as solid, so we just write it as solid. Okay, and is that out for notes?
Yeah, the rest is like textbook.
Okay, so we'll leave that there.